Okay, so I'm going to teach you how to automate that process that we just went over in the last video. So basically, we start off with our stack with a red and blue channel. We're going to go ahead and we go to plugins, macros, and then record. And then this box shows up right here, our recorder. It's going to record every step in the IJM language, which is the ImageJ coding language. And so we're going to start off with our image right here. And we're going to go to images, stacks, stacks to images. So we only want the blue. We can get rid of the other one. And then we're going to go ahead and do image type 8-bit. Okay, and then Control Shift T, because we want a threshold, which remember that's like segmentation. We want to segment out all of our little nuclei. So we're going to click apply, and then we're going to go to process, binary, make binary, and then we're going to go to analyze particles. And these were our settings that we ended up liking. Outline, I think I'm going to do overlay masks. I think I like that best. I'm going to press OK. And then we can check to see if that looks really good for our nuclei. It looks like everything is counted correctly here. Okay, so now we're going to go ahead and take all of these steps right here. So you just go inside of there and put Control-Alt, Control-Copy, and now we take it to our little coding thing. This is where we make our macros. So we're just going to go to File, New. So we're creating a new macro, and we're going to go ahead and write our code like down here. We'll just paste it, and we're going to go to Language, IJ1 macro. And then we're going to go to one of the folders. So I'm going to provide you with one of these, and then you guys are going to have to like play with them and modify them to automate them for different things. So nuclear area fraction. I think this is the one that I like for right now. So we're going to go ahead and take whatever we want from here up until the end right there, Control Copy. And we're just going to paste it over here. So what we're doing right now is we're taking the folder function, and then up here, I'll show you how to modify this right now. Let's go to options and let's increase our font size so you guys can see better. Let me increase it a lot. Okay, now you guys can see. So up here, we're just going to comment out what this is for. So we're going to say, with this macro, we will be able to take a Z stack, select the second channel, which in this case is blue, and threshold it and make it binary and analyze particles so that we can quantify the area and perimeter of these cell nuclei. Okay? And then we start with the code. So here, input directory, that's going to be the folder. It's going to open up a little text box, and it's going to have us choose what folder all of our Z stacks are in. And then output is going to be the folder where we want to save our new information. Suffix is .tiff, so it's going to take all of the .tiff images from there. And then this is the for loop that was given to us for the folder option. And then this is where it ends. It says function, process file, input, output file. And then this is where you start writing your code. And then whenever you're ready to be done, you end it like this: run, close all, clear results. And then this is like the actual code we want. So let's go look at the code that we have so far to see what we want to keep. So we're going to run the properties, to scale everything at 0.17 because this is a 20x image for our microscope. It's 0.17. That's the pixel to micron ratio. And then stack.setSlice, this line of code is to select which slice you want. So slice 1 was the red channel, so we want slice 2. And then we want to duplicate that, and we're going to call it blue because that was blue. We don't want the second slice. Oh, I could have just had that, but that's fine. Okay, so far we calibrated the image, we selected the second slice, we don't need to merge. Threshold, we are thresholding, but it's going to be different. Okay, so we can erase all of this. We ended up not needing, I like to look at my code first to see if I can reuse any of the commands, but I think this is good. Okay, so now we can go ahead and grab all the stuff that we copied, that we recorded from our macro, Control X, because we want to take it and we want to put it right here. Control V. Okay. And now we can say run stacks to images. We don't need to do that because we already selected the second slice. Anything that's specific. So here you see select window and it says phalanx P4, all that. That was the actual name of our image. We don't want anything that specific. It won't work in a folder type thing. You want vague things like this one, stack.setSlice n is equal to 2. So it's just going to take your second slice from no matter what the image is called. It can be called anything and it doesn't matter because it will just take the second slice, it will duplicate it, and it'll label it blue. Okay, so then after we duplicate it, we turn it into an 8-bit image because I think it's like a 16. And then we're doing the Atsu, that's the Control-Shift-T button. And then we selected Atsu, that's what we did. Run threshold, it kept numbers for us, those were it. And then set option, black background. Okay, and then convert to mask, that's when we made the image binary. I don't think we need to do that twice. So that was making the image binary. The code for that is run convert to mask. And then we decided to analyze our particles. And if you remember, we went from 15 microns to infinity. And so that's what it says right here. So that's perfect. And then save as TIFF. So it's going to save our image and as a TIFF. And we're going to say, we're going to call it segmented. Okay, and then I don't actually want it to close everything. So I'm gonna silence this out. I'm gonna do one image at a time, actually, or maybe two for now. Run, close all, run, clear results. I'm not gonna do that right now. Okay, let's run this. Wait, hold on, not yet. Okay, now let's practice running this code. So we're just gonna hit run, and then now you can see it's asking you for the input directory. So it's saying, where do you want me to grab your images from? And I just created this practice folder with 2 Z-stacks. So we're gonna say grab the images from there, and then whenever you save your stuff, you always go into that original folder and you create a results folder. And then you label it with what results are these. So we're going to say analyze particles. That's what you did here. And you want to label it because you're going to be doing lots of things. Sorry, those are my dogs. So we're going to say save it in this output directory select. And now you can see that it's like, I'm not doing anything. It's doing everything for me. Okay, so you can see, sorry about my dog. So you can see that it's doing everything for me. Here's my summary tables. Sorry. Boba, can you stop? Okay, so you can see my summary tables. You can see, let me let her out. So here you can see my segmented image, and then we have the original image, we have the results table. Okay, so I automated the code and I modified it a little bit because it was still selecting the first channel. So it has something to do with stacks and the commands. So I ran this one instead. It's run, instead of the stack dot set slice n equals 2, I commented that one out. That's why it's in green. So it's not going to run. We're going to run this one instead. It's run duplicate. So it'll select the first image in that folder. It'll duplicate it and it'll say duplicate channels equals 2. So it's going to duplicate that second channel. And then we're going to run 8-bit. Oh, remember, the second channel is the blue. Then it's going to run the 8-bit. So that's going to make it from 16 to 8-bit. Then it's going to do the threshold, the Atsu one. Then everything else is basically the same. So we're going to go ahead and run that right now. Run. So it's asking for my input directory. So we're going to go back to the practice folder, select that. It has to be selected in blue. And then output directory where we want it to go. So it's going to go into the results, analyze particles, select. So boom, it did everything for me already. It's done. And now we can look at this and we know that these are all nuclei. So that's how we know. Previously, it had selected the cells, and that's why I knew something was wrong. But like, this is beautiful. I know for a fact that these are the nuclei. So yeah, and that's how I automated it. You see how fast that did 2 images for me. When you do it manually, it takes like 5 minutes. And here, I think it did in like maybe 3 seconds. So yeah, that's the power of automation and combining ImageJ with coding.